Looking at this particular question, of course, we are going to diagnose how we can easily solve it effectively to get the correct answer, and this is under the topic functions. We want to look for the inverse of a function of g of f, as well as look for the value of element which is invariant to that particular component. Let's look at the question. The function f and g are defined by f of x equal to x plus 1 divided by 2x plus 3, where x is an element of real numbers and x is not equal to minus 3 over 2. Given that we have g of x as well, 3x plus 2, where x is an element of real number, then asking us in section A to express in a similar manner the function g of f inverse. Now, if we look at g of f of inverse, what we are going to do is we are going to start with g and try to rewrite g. Anywhere that we see x inside of g, we replace it by all of the function of f. Then we need to solve until we have the value of that. And once we have that, we are going to equate the answer equal to y, and the answer equal to y. Now look for the value of y. Now, once that part has been completed, where you have successfully get y to stand alone, then that answer is g of f of x. To get the inverse, which is g f inverse, then this time we need to use that y equal to, which is the g of x. Now make sure that we make x to stand alone on one side. Once we get x to stand alone on one side, then it is the g inverse, which is g of f inverse. Then from the b part, or for the b part, we are going to make sure that we use, since the variable have been given, that we should use g of x, then we are going to express the g. But in this time, we are going to use the expression of g and equate it to be equal to x and solve for x. X is going to be the value or the element which is the invariant. Let's look at what we have. Looking at this question, just as we have explained, we have two things we need to look at in this question. The first question, which is the first one here, we are looking at g of f inverse. That is g of f inverse. As we have earlier stated, to get g of f inverse, we must first of all try to get g of f of x. And once we get g of f of x, then we equate it to equal to y and solve for y. So beginning here, if you have something like this, g of f of x as an example, we need to first of all solve this. And to get g of f of x, we must start with g, and anywhere that we see x inside of g, we replace it by f of x. What I mean is, starting with g, this is g, we are going to start with 3, and anywhere that we see x, we input this one, which is f of x. That is exactly what I'm trying to say. So in other words, we are starting with g, which is 3, as you can see here, 3. This is x. So it means that we replace it with x plus 1 over 2x plus 3. So into x plus 1 into 2x plus 3, then plus 2. Plus 2. This is exactly what it means, since we are looking at g f of x. So now we need to express it. 3 into x is going to give us 3. X plus 3 into 1 is 3 over 2x plus 3 plus 2. This is what we have now. And seeing this, it is still the same as looking for the least common multiple, because this is plus here. We just try to simplify it. This and this is this, 2x plus 3. So 2x plus 3 times 1 under here is the same as 2x plus 3. So 2x plus 3 if we divide by this, we just have 1. 1 times this is 3x plus 3. 3x plus 3. 2x plus 3. If we deal with this one, we are still going to just have 2x plus 3. Then we multiply by 2. We are going to have 2 into 2x plus 3. So we replace this plus, this 2 into this one, 2x plus 3. So we have just, what we have done is we have compressed this as a whole into this simple compression that you can see here. So we have just compressed. So let's now try to make it in a way that we try to group it. 3x plus 3. 3x plus 3 plus 2 times 2x is 4x plus 2 times 3 is 6 divided by, we still have 2x plus 3. 2x plus 3. Okay, we now have this. Let me try to, we have this now. Let's see what we can do right now. Looking at this, if we group 3x plus 4x, we are going to have 7x. As you can see here, we are going to have 7x plus 6. That is 7x plus 9, because if we group 6 plus 3 is 9. 4x plus 3x is 7x. So we have 7x plus 9 divided by 2x plus 3. 2x plus 3. So now, we said that if we do, as you can see, if we look for g of x, g of f of x, once we get the answer, let's equate it as equal to y. Now the answer of this is 7x plus 9 over 2x plus 3. Let it be equal to y. So this is the same like y over 1. If we cross multiply on the other side like this, we're going to have y into all of these times 7x plus 9 times 1. So it is the same like 7x plus 9 times 1 is the same like 7x plus 9 is equal to this y into 2x plus 3. So y into 2x plus 3. We have this now, as you can see. Now let's try to make sure we regroup. Okay, let's express this one. We have 7x plus 9 is equal to 2 times y. 2x times y is 2xy. So we are going to have 2xy plus y times 3 is 3y. If you look at it, as you can see here, something is common. Y and y is common. So we can put the common term. As you can see, this is common. Here, y and y is common. So we can express in a way that we put y outside of the multiple bracket. So we can still say 7x plus 9 is equal to, since y is common, we put it outside and try to factorize. We have 2x plus 3. You can see it's the same as this one here. So what do we do now? Since y, we can now look for y alone. So y will be equals to 7x plus 9 divided by 2x plus 3. So to make y to stand alone, we must divide all the other side. So we can still say that, as you can see here, we can say that y into 2x plus 3 equal to 7x plus 9. We divide both sides by 2x plus 3, 2x plus 3, so that this is going to cancel this and y is going to stand alone. So we now have the value of y. So if we look at this like this, y will be equal to 7x plus 9 over 2x plus 3. Now we have gotten y equal to 7x plus 9 divided by 2x plus 3. This is the normal g of f of x, which we have equated as y. So since we now know g of f of x, to get the inverse of g of f of minus 1, then we must, at this level, make sure that we make x to stand alone. In other words, instead now of y to be alone on one side, we must now look for x to be alone. Once we succeed to get x as a value, then that value is gf of minus 1. So to make sure that we get x at this level, then we must still the same like equal to 1 and try to cross multiply on both sides. In other words, y is equal to be 2x plus 3. That is y into 2x plus 3. You see here, let's put y into 2x plus 3 will equal to 7x plus 9. At this case, we must make x to be on one side, which is the left-hand side of this expression. So we must gather all x on one side as like term. Let's try to multiply this. We have 2xy. 2x times y is 2xy plus 3y is equal to 7x plus 9. Let's now try to group like and unlike terms together. We bring this 7x here. We're going to have 2xy minus 7x. So we have 2xy minus 7x will be equal to, we have this 9. We carry this one on the other side since we don't need y this time, minus 3y. Now we have to factorize to make sure that because x is common, we put x outside of the bracket, then 2y minus 7 will be equal to 9 minus 3y. We need to make sure that x stand alone. In this case, we have to now divide all the side by 2y minus 7. So divide this side by 2y minus 7. We also do the same here, 2y minus 7. So this is going to take up this, and we are left now with x will be equal to 9 minus 3y divided by 2y minus 7. So since x is now alone on one side, then this answer is g f of minus 1. So this is the correct answer. In other words, once we equate to y as the first part where we have y, which is the normal g of f of x, which is y is equal to 7x plus 9 divided by 2x plus 3, we need to make sure that we now look for x to be on one side alone. And once we succeed to get the x, then and get the value, then it is gf of minus 1. So this is the correct answer. Let's now look at the B part of it. We state that we should look for what is called the invariant of G. In other words, as we have explained, invariant of G simply means that we must take G and equate it to equal to X and look for the value of the domain, which is the element. So what it means is that this is G, since they are talking about G here as description, this is G. So we must say 3x plus 2 and equate it to equal to X. So we are going to say, let's try to look at itself. We are going to state that, let's rewrite G, which is 3x plus 2. We must equate it to equal to X. Now, if we equate to X, then we need to look for the value of X. In other words, if you look at this, we are going to say that we try to group like terms and unlike terms and separate them to get the element of that domain as invariant. So it is going to be, let's group it. Let's carry like terms on the other side. 3x, let's bring it here, minus x is equal to, let's carry 2 there, which is unlike, which is it becomes minus 2. So 3x minus x is going to be 2x So we are going to have 3x minus x equal to minus 2x. So 3x minus x will give us 2x is equal to minus 2. So to make x stand alone, we divide both sides by 2. This 2 we take off this, and we have this take up here 1. So we have x as equal to minus 1. So this is the element that make the invariant. So x, which is equal to minus 1, is the element that define this, the B part that we should look for the element. So the element here is minus 1. This is the complete answer of this question, and it can give us a total of 9 marks.